Adding vectors. Now here on the title page you'll see that I have some arrows. A vector is an arrow, remember. This part here, the line, the length of the line is the magnitude, means how much. And then you have your arrow part, which shows you the direction. So remember, vectors, they are magnitude and direction. What we talked about before, a little review here. If the forces act in the same direction, we add them. If they act in opposite directions, like a tug of war, we subtract them. Alright, we've done that before. We have some examples coming up, so we'll talk about that then. Alright, here's one. You have Joe and Ann, here they are riding in their car, and Joe runs out of gas. So Joe and Ann are both going to push the car. Joe pushes with 200 pounds of force, and pushes with 180 pounds of force. Alright, now hopefully they're pushing in the same direction, alright, or they're going to be fighting each other. So we'll assume that they know. So they get in the back there and they start pushing the car. Alright, so since they're going in the same direction, you're going to add. So it would be 200 plus 180 is going to give you 380 pounds, and the direction is forward. Alright, because they're both pushing forward. Now here you have a tug of war team. Alright, so you got this side against this side. Now, if they both pulled with 750 pounds of force, that side pulls that direction, that side pulls that direction. Since they're in opposite directions, you subtract. Alright, so your net force here is going to be 0. So what happens is nobody wins, and the net force would be 0, and that's what we call balanced or in equilibrium. Now, what happens when they do not act in the same plane or same line? Alright, well, you have to solve them graphically. Alright, and when you add up all forces they can go in all different directions, they call that the resultant force. Alright, we talked about that before. Okay. Alright, the way this works, okay, with graphical analysis, the vectors have to be drawn as accurately as possible. Now, another way of solving these problems is by using trigonometry. Alright, you can see I have that done as a third point here. But you'll have sometimes people will say, well, I never had trigonometry, and I can figure out angles. Alright, well then they have to use a different method, and this is the other method, graphical analysis. But I will tell you this, the trade-off is that you must be very accurate for it to work. Okay, you can't just eye it up. You have to use the tools. The tools are the rulers and the protractors. Rulers measure the magnitude. The protractors measure the angles so that you can get your direction. Okay, I've got a whole bunch of steps here before we actually start with some pictures. But one of the first things that I suggest is look at the problem, and you need to decide on a scale. Alright, and a scale is like a key for a map. 1 inch equals 100 miles. Well, in this case, 1 centimeter is going to equal a certain amount of force. So 1 centimeter could equal 10 pounds. If you wanted, you could use English. You could say 1 inch equals 20 pounds. Whatever it is that works for you. So you're going to need to use a ruler for that. One of the suggestions I make to you is that once you've determined your scale and you know how long that your vectors are going to be, all right, you want to place your dot. And this is where the dot is where your vectors are going to come from. All right, that's going to be the end of the vectors. Okay. And when I say the end, it's the end of the line. Maybe you want to say the beginning, if that helps you. It's the end of the tail. I guess that's really what I'm trying to say there. But anyway, when you place your dot on your paper, you need to make sure that it's located in a spot, since the vectors are going to radiate out from that point, that it'll all fit on your paper. The next thing that you do once you have your two vectors are drawn, make sure that you're using, or actually even when you're doing this, make sure you draw them in the correct direction. All right, so if it says that's supposed to be, one is set 35 degrees off the horizontal, you make sure you draw that. All right, once you have that done, make sure you draw a parallelogram. Now what a parallelogram is it can be a rectangle. The sides are parallel. All right, that's the thing to remember. All right, and we use what we call the head to tail method, and you'll see that shortly. You're going to draw your resultant. It's going to be from the dot you put on your paper in the first point to the end corner. All right, that will be your resultant. And what you're going to do is you're going to measure the length of that, and then you're going to measure the angles on either side using a protractor. All right, so let's take a look at a problem. In this problem here, you have a boat. All right, sometimes what you need to do with problems is you need to draw them out so that you can kind of figure out what are they asking me. So it makes a little more sense. So drawing is good. So here we have this boat, and we have two people, and they are pulling on ropes that are attached to the boat. Notice at the same point. This is where that little dot would be. And it says in our problem, the person on the right of the boat or on the dock pulls with 40 pounds of force. So this vector here is 40 pounds. And it says the person in front of the boat or on shore pulls with 30 pounds. So this person's not pulling with as much force. What is the resultant force of the boat? Okay, well, first of all, where do you think the resultant is going to be? If this guy's pulling that way and this guy's pulling this way, what direction is the boat going to go? Well, somewhere in here. Okay? Somewhere in here. All right. I've got rid of extraneous things here. So now we're looking at the picture of our vectors. So this is where our dot went. Once you have your scale, what you're going to do is you're going to draw your vectors in the right direction and the scale. So you got this one equals 40 pounds. So when you were doing this drawing, you kind of have to, you'd have to choose, you're going to use centimeters, you're going to use inches, what are you going to use? All right, so this one is longer than this one. Once you have those, you're going to make your parallelogram. And what we were talking about, the head to tail method, is what you're going to do is your tail is here, and then the head is here. Tail is here, head is here. All right, right here is your tail and head, and then here's your tail, and this is your head. So right where the arrows come together is the corner that you're going to be going to. So it's from the dot to the far corner. This thing right here is called your net force. And what you do is you measure that. And, in this case, if we were to say, okay, we use 1 centimeter equals 10 pounds. Well, then in this case here, you would measure this to be 5 centimeters. All right, so then that means that would be 50 pounds. And then you take your protractor, measure this angle right here, and you measure this angle right here. Now, notice one of the things here, this angle is a little bit smaller than this angle. The side that pulls with the greater amount of force has a tendency to pull, all right? This net force is going to be closer to it. So if this person pulled with a lot more force, that means that this vector here would actually be closer to it. It would probably be down in here, okay? So that's one of the things that does happen. So just to kind of give you an idea of what the angles were there, if it were 50 pounds, then the one angle would be 53 degrees, the other one would be 37 degrees. Now what you want to do is you want to draw that. All right, and choose your scale that you want to use. If you want to use inches, as like I have here, the line was 5 inches, it would be 50 pounds. If you chose centimeters, all right, 1 centimeter equals 10 pounds, then it would be 5 centimeters. 5 inches is pretty big, so that you don't have any trouble seeing. What I want you to do is try that, all right, and see what you get. And hopefully you'll be getting the 53 degrees and the 37 degrees as well. Well, that wraps up adding vectors for now. Try that. and you should get the same answers. All right? See you next time.